All right, so hi guys. So um in the I tried to make a video over how to actually um solve a system of nonlinear equations by graphing and state, the number of solutions as well as the points of intersection. It took me way too long, so I'm going to try my best to not over explain this. And if it is really long, I do apologize, guys. I am going to do this step by step because, well, yeah, I mean, it is a lengthy problem if I am going to explain it in detail. So I'm just going to get started right away. It says solve the system of nonlinear equations by graphing, state the solutions as points of intersection, if any, and state the number of solutions. So we have this system here, y equals x squared plus 4x plus 2, and 2x minus y equals negative 5. So the first one that I am going to graph is the quadratic. This is a quadratic equation or a quadratic function in this case. So we're going to go ahead and just graph it right away. And if y'all don't know what that is, it is a parabola. Whenever we have a ax squared plus bx plus c, if a is greater than 0, then it points upwards, and if it's less than 0, it goes downwards. So I just want to state that very clearly. Now, to graph this function, we know that if we have the following, ax squared plus bx plus c, and this is our equation, one of the things we have to keep in mind is that our y-intercept will always be the point 0, comma c. Okay, so I just want to state, make that very clear. So here on our quadratic, on this quadratic equation here, we know we have y equals x squared plus 4x plus 2. Putting this in this form, I'm going to go ahead and just, write it so that we can define a, b, and c. So we have y equals 1x squared plus 4x plus 2. And the reason why a is equal to 1 is because anytime there's no, it's an invisible 1, really. So here, like I said, we know that our y-intercept is 0, comma c. We know that a is equal to 1, b equals 4, and c is equal to 2. So our y-intercept will be the point 0, comma 2. So right away, I'm going to go ahead and plot that in there. And I'm going to use a different color. So I'm just going to I'll put it in this color for now. So we're going to just plot that point, and that is the y-intercept for the quadratic function. So then we want to notice that the axis of symmetry is a vertical line. So it's going to be x equals, and the formula will be negative b over 2a. So plugging in the values, we have negative 4 over 2 times 1, which equals negative 4 over 2, which is negative 2. So then our axis of symmetry is x equals negative 2. So we're gonna kind of draw a dashed vertical line. I'm gonna do it this way. So this is gonna be our axis of symmetry, guys. So we're just gonna do it this way. and that will be the axis of symmetry, x equals -2. I'm trying not to go so in depth with this, guys. If y'all have questions about the axis of symmetry is just, I'm just going to define it very quickly. It's when you have a parabola, whether it is up or down, the axis of symmetry is literally just what splits the parabola in half. So this would be our axis of symmetry, and it is in terms of x equals some number, right? Now, we plotted, we went ahead and labeled that, and now our vertex is literally the middle of the very minimum point of the parabola. The vertex is defined as the point, so it's the axis of symmetry -b over 2a. And then comma f of -b over 2a, whatever, you know, we basically are going to evaluate it at the axis of symmetry, evaluate our original quadratic equation or function at that point. Because we know that the axis of symmetry ended up being -2, we're going to say f of x, and we're going to rewrite it this way. F of x equals x squared plus 4x plus 2. We're going to evaluate f of -2 because that is the axis of symmetry at x equals -2. So we're going to go ahead and evaluate that. F of -2, let me just do another color. Sorry guys, give me 1 second. Is going to be the quantity, and it's going to equal, I'm sorry guys, hold on. The quantity -2 quantity squared plus 4 times -2 plus 2. This equals 4 minus 8 plus 2, which is really -4 plus 2, which equals -2. So we know when x equals -2, y is equal to -2. So the vertex is the point -2, comma -2. We're going to plot this on the Cartesian plane, or the coordinate plane here. So we're going to plot it right over here. So it's going to be, I'm going to do it in, oh gosh, dear. So it's going to be right here, -2, -2. Now you want to find two other x values at which, or 3 rather, I'll do 3 in this case, at which, you know, when you evaluate the quadratic function. So evaluate the function at 2 different x values, 2 or more. Doing so, let's pick to the right or left. Really, we're going to do f of -1. So when x equals -1, I know f of x equals, I'm sorry guys, f of x was x squared plus 4x plus 2. So when x equals -1, f of -1 will equal the quantity -1 quantity squared plus 4 times -1 plus 2, which is equal to 1 minus 4 plus 2, which is -3 plus 2, which equals -1. So when x equals -1, y equals -1. Wait a minute. I'm sorry. Actually, no, yeah, I'm right. So when x equals -1, y equals -1. So it's very strange that it's kind of the same as this, where it's -2, -2, -1, -1. Anyways, now we're going to pick the point x equals 1. So now evaluate f of 1. So we're just picking one more point, guys, because we want to make sure that we put as many points on the parabola as we can. So we have f of 1 equals the quantity 1, quantity squared, plus 4 times 1, plus 2, which equals 1 plus 4 plus 2, which equals 5 plus 7, plus 2, excuse me, which equals 7. So when x equals 1, y equals 7. So you want to plot the point 1, comma 7. So let's plot it right here. So we're going to go all the way over here. Now you want to go ahead and reflect the points about the axis of symmetry. So reflect. Now reflect the points the plotted points about the about the axis of symmetry, or AOS, right? So we're going to go ahead and grab the points, and you want to be careful with reflecting. So we're going to go ahead, when it's like this, we have, so let's see here. We're going to grab this point here. We're going to go 1, 1, so we know it's -3, -1. So let's plot that. And then we're going to do it at y equals 2, so we have 1, 2, 1, 2. So you're going to plot the point right here. Okay, so do this one. And then you're going to go up to 1, comma 7, and you're going to do the same thing. So every point on the right side, guys, you're going to reflect them. 1, 2, 3, 1, 2, 3. So you want to make sure that whatever units you go on the right, you do it to the left. That's how we reflect. And so finally, what we're going to do is we are going to draw the smooth curve through the points. So draw the parabola that we ended up with through these points. And so this is the parabola that we have. You know, this is the first, you know, we've already done the first part of this. Now we want to go ahead and graph the function f of x, or I'm sorry, graph the second equation. So now graph the second equation. This one is a linear equation, and it is the following. It is going to be, and give me 1 second. It is going to be the following. It's going to be, I'm sorry, hold on, guys. Give me a second. Now we want to graph 2x minus y equals -5. So here, what we're going to do is we are going to solve for y. To do this, we're going to solve for y and label y-intercept and slope. So what we're going to do here, we have 2x minus y equals -5. To solve for y, we're going to add y to both sides first. So this will end up giving me 2x is equal to y minus 5. And so then from here, we're going to go ahead and divide both sides by 2. So we're going to go ahead and do the following. Let me see here. I'm sorry, guys. Give me a second. So we're going to have y minus 5 and then all over 2. So this one, I will admit, guys, it is kind of difficult to graph this one for some reason. Oh, I'm sorry, guys. I'm sorry. We're solving for y, not for x. Excuse me. So, solve for y. Excuse me. I solved for x instead. I'm sorry, guys. We're then gonna add 5 to both sides. That's why I was confused for a second. 2x plus 5 equals y. So we want to go ahead and label, and remember the slope-intercept form of the equation, guys. I know this is a lot of terminology, but I really want to make sure we're set up for success. It is y equals mx plus b. Where m is your slope, and b is the y-intercept. Remember that the y-intercept as a point is going to be at 0, comma b, okay? So in this case, our y-intercept is going to be at the point 0, comma 5. So you want to plot the y-intercept, and so like I said, b is equal to 5 in this case. So then also my m is equal to 2 because that's the number in front of x. So then we're going to plot the y-intercept here. So we have the y-intercept at 0, comma 5. So I'm going to do it. Oh, dear God. I'm running out of colors. I'm sorry, guys. Hold on. I'll do it in... Oh, dear. I'll do it in this color, whatever. So we're going to plot the point at 0, comma 5. And now remember that the slope is rise over run. Remember, m is rise over run. This is a lot of colors, guys. I do apologize. So we're going to go... It's really... So the slope was... I'm sorry, it was 2, right? So the slope is 2 over 1. And so we're going to go up 2 units and then to the right 1 unit. So then this will end up being the following. So we have this going on. And so from the y-intercept, we're going to go up 2 and to the right 1. So we're 1, 2, 1. So we know that that is a point. And then we're going to go one more time. 1, 2, 1. So we know that this is another point. And then now remember that 2 over 1, you're going to do the reverse. 2 over 1 also means negative 2 over negative 1. There's a reason for that. And that is because I'm going to do the opposite. Instead, now I'm going to go down 2 and to the left 1 unit. So we're going to do, because you need to do it on the other side. So I know that if that sounds confusing, guys, just think of the y-intercept going from this point to this, or this point going to this point going this way. So we know we're going to repeat that sequence, or that you know, over and over. So we know that there's going to be a point at negative 1 comma 3. So, and then you're going to do it again until you reach, you know, until you reach as many points as you can. And so we have, again, we're going to do, oh dear God, 1, 2, 1. So we have a point. Hold on, guys. right here. Oops, no, that's not it. Right here, sorry. And then again, you're going to do it again. So we're going to do 1, 2, 1. So it's going to be right here. And then again, 1, 2, 1. And then 1, 2, 1. 1, 2, 1. 1, 2, 1. And then I believe we reached the end of that. Give me a second. And so finally, guys, we can clearly see that if we draw the linear equation that we were given using a straight edge, we can clearly see, and this is drawn to scale, guys. It's not perfect, but let me try. Something like this, okay. And we can see that the points of intersection here, so we want to see where does it intersect the green parabola. It intersects the points of intersection are right here and over here. So the points of intersection are at, it's going to be -3, -1, and 1, 7. So the two, and thus the system has two solutions. And that is going to be the final answer to this problem, guys. The only reason why this is so lengthy is because we have to understand how to graph the linear one as well as the quadratic. I made it detailed for those of you that struggle with, with how to do these kind of problems. So I do apologize if it's really lengthy. But if anybody does have questions over this, please let me know. And if anybody, if y'all have any requests of any videos, also let me know in the comments below. And thank you so much for watching, guys. And with that being said, please like, comment, and or subscribe. And I will see you guys in the next video. Bye, guys.